Today we are talking about computation with scientific notation. Kind of rhymes, huh? So you're going to come up and have a problem something like this. You have a number in scientific notation and another number in scientific notation. Now remember, if there's two parentheses next to each other, it represents that they're being multiplied. First thing to notice is that we have two things being multiplied in parentheses and two things being multiplied in parentheses. Multiplications going on between those parentheses. Now, if you remember back to your properties of multiplication, the associative property allows us to reorganize how they're grouped. So that is going to be the first thing we're going to want to do with this. If you notice, we have a 1.5 and a 1.2, and we have a 10 to the third and a 10 to the fourth. So I'm going to change this order a little bit. I'm going to put 1.5 times 1.2. And then I'm going to take 10 to the third power times 10 to the fourth power. Now remember, this is the associative property of multiplication. We can do this. So now this is looking a little bit easier for us, right? 1.5 times 1.2. Can we solve that? Yes. So we're going to 1.5 times 1.2. We need a 0, 1, you get a 3, 5, and a 1. Let's get this up a little bit. A 0, an 8, and a 1. You move the decimal once here and once here. You don't have to move it twice in the answer. Your answer will be 1.8. So 1.5 times 1.2, let's get this up a little bit, will give us 1.8. Now, 10 to the third times 10 to the fourth. We've been talking about these exponents. They have the same base of 10. When we're multiplying two things that have the same base, all we have to do is add those exponents. So we could write that as 10 to the 3 plus 4, which will give us times 10 to the 7th. This is going to be our answer. Make that decimal a little bit more obvious. Because of the associative property of multiplication, we're able to regroup these. It's a little bit easier taking 1.5 times 1.2, and 10 to the third times 10 to the fourth is also a little bit easier. And here we go, we got our answer in scientific notation. So let's look at another example. So this time, we are dividing. Now, we're going to be able to do the same thing we did last time. We're going to break this up. So what I'm going to do, just like last time, I'm going to take 7.8 divided by 5.2 and multiply that by 10 over 4 divided by 10 to the second. So let's just do the tens quick. We know that when we're multiplying when we have two numbers that we have two of the same base that are multiplying, we add the exponents. When we're dividing, we subtract the exponents. So we're going to take 10 to the fourth minus one that's on the bottom, 2, we have 10 to the second. Okay, so we have that part done. But we need to figure out this other side here, the 7.8 divided by 5.2. So, you know, this would be a little bit easier with the calculator, but it's not too bad. When we have a 5.2 and a 7.8, we don't want to divide by something that's a point, so we're going to move that decimal over. Change that to 52, and change this to 78. Does it go into 7? No. Does it go into 78? Yes. It goes in there once. 52, a 6, and a 2. We have to add a 0, which there's a decimal right here. Don't forget that decimal. This is a 78, decimal there. Decimal needs to come up here as well. Okay? We bring that 0 down, 260. 50 would go in there 5 times, so that would give us 250. If you add another 10, that'd be just right. So 5 times 2 is 10. Carry the 1. 5 times 5 is 25. Plus 1 is 26. No remainder. Comes out to a nice 1.5. I wanted to say even, but it kind of is even, right? If we only had one decimal in each of those, and here we only have one, that's nice. We don't have some big, long, repeating number. So we simplified this. We got 1.5 being multiplied by, we simplify that, and we got 10 to the second. So again, we could just break this down, work with these two coefficients and these two powers of 10. That makes it a lot easier, right? Simplifying this and this individually and then putting it all back together for your answer. So 1.5 times 10 to the 2. Now you could write this number out explicitly. You could write 7, move the decimal over 4 places, divided by 5 point, then move that decimal over, it should become 520. For these ones, it's not really necessary. Working through these steps isn't too bad. Now, a place where it might be a little bit easier at first to write them out explicitly is something like this. The difference we have here, again, we have two numbers in scientific notation, but this time we are adding them instead of multiplying or dividing. That changes things. So for this one, I'm going to write this one out. I'm going to write it out explicitly. Now, this one has the higher exponent. We're adding them, so I mean, I could put them on either part, but I'm going to put this one on top because it's going to be the larger number. So we have a 9, 2. I move the decimal once, so 1, 2, 3, 4, 5, 6. We have 9.2 million. Now this is 8.5 times 10 to the 5th. We know that this is going to be one place smaller, right? Because it's 10 to the 5th power. So I could start here. I don't even need to count my zeros. I already know it's going to be one smaller, but for the sake, we could say I moved it 1, 2, 3, 4, 5. Now we're going to add these. 0 plus 0, 0 plus 0, 0 plus 0, 0 plus 0, 0 plus 5, 2 plus 8. So now we have 10,050,000. A lot of times these questions, they're going to give you two numbers in scientific notation that add or subtract, and they're going to want a number written, an answer written in scientific notation. Is this in scientific notation? No. What do we have to do? Similar to what we did up here. Got to put it back in that format. So we need to move the decimal how many places? 1, 2, 3, 4, 5, 6, 7. I have 1 point. We want to include this 5 in our scientific notation. Times 10, we moved it how many places we said? 7, 10 to the 7th. Which will also be 10,050,000. And that's how you do computation with scientific notation.